Today we're going to continue with looking at solving linear equations, but in this case we're going to be looking at two equations and we're going to want to find the value that makes them both true. So one of the ways that we have of doing that is setting the equations equal to each other. So let's take the equation y sub 1 is equal to 7 times 3x minus 2 plus 5. And we have y sub 2 is equal to 6 times 2x minus 1 plus 24. And we're wanting to find out or to find the values such that y sub 1 equals y sub 2. Find the value of x that makes them both true. Well, one way to do this is simply to set your two equations equal to each other. So 7 times 3x minus 2 plus 5 is equal to 6 times 2x minus 1 plus 24. And now it's like the other equations that we've solved. We want to go through and we want to remove the parentheses. So we have 21x minus 14 plus 5 is equal to 12x minus 6 plus 24. Then we can combine our like terms. So we have 21x and negative 14 plus 5 would be negative 9 is equal to 12x. Negative 6 plus 24 would be positive 18. And after we've removed parentheses and combined like terms, we want to get our variables on the same side, or variable terms. So we're going to subtract 12x from both sides, which gives us 9x minus 9 is equal to 18. Then we can add 9 to both sides, and we have 9x equals 27, so x equals 3. So the value that would make both of these equations true is when x equals 3. If we wanted to check, we could substitute in. So we could take the first equation and have 7 times 3 times 3 minus 2 plus 5. Well, that would be 7 times 9 minus 2 would be 7 plus 5. So we have 49 plus 5 is 54. We take our second equation, 6 times 2 times 3 minus 1 plus 24. Well, we have 6 times 6 minus 1 is 5 plus 24 would be 30 plus 24 or 54. And so we found the value of x that would make both of the equations true. If we wanted to look at it in a little different way, it's possible that we could have two equations. Y sub 1 is equal to x minus 3 over 5, and y sub 2 is equal to x minus 5 over 4. And maybe you were asked at that point to find when y sub 1 minus y sub 2 is equal to 1. You can be given equations and asked to do several different things with them. Well, again, you set up an equation of y sub 1, which is x minus 3 over 5, then minus y sub 2, x minus 5 over 4, and you want to know when those equal 1. Well, we go back and we get a common denominator, which for 5 and 4 would be 20. So we're going to multiply each term by 20. 5 goes into 20 4 times. So we have 4 times x minus 3 minus 4 goes into 25 times. So 5 times x minus 5 is equal to 20 times 1 is 20. Removing our parentheses, 4x minus 12. Then we have a negative 5x plus 25 is equal to 20. 4x minus 5x would be negative x plus negative 12 plus 25 would be positive 13. Then subtracting 13 from both sides, not 30, but 13. We have negative x equals 7, dividing by negative 1 because we want a coefficient of positive 1, x equals negative 7. And if we check this, then we could go back in negative 7 minus 3 over 5 minus negative 7 minus 5 over 4. Well, this would be negative 10 over 5. This would be minus a negative 12 over 4. So we have negative 2 minus a negative would make that a plus 3. And negative 2 plus 3 is positive 1, which is what we were wanting to get. We could have problems where we want to find a value of x so that y equals 0. We're wanting to find the zeros. So if we have the equation y is equal to x plus 6 over 3x minus 12 minus 5 over x minus 4 minus 2/3. And we're wanting to know where y equals 0. So we're simply going to replace y with 0 is equal to x plus 6. Now, at this point, I'm going to go ahead and factor that denominator because when we go about finding common denominators, we need them in factored form. Well, that one has a common factor. Remember, the first factoring you always look for is a common factor, and it has a common factor of 3. So we could write this as 3 times x minus 4 minus 5 over x minus 4 minus 2/3. Okay, we're going to have to go through and multiply each term by the common denominator. Well, right here our factors are a 3 and an x minus 4. We have a factor of x minus 4, a factor of 3. So our common denominator is going to be 3 times x minus 4. And we'll multiply this each side by that common denominator. So 3 times x minus 4 times x plus 6 over 3 times x minus 4 minus 3 times x minus 4. And I know sometimes it may get a little old to write all of this down, but I found over the years that it helps. It keeps you from making mistakes uh, and leaving terms values out. So even though it takes a little while to put in all of those 3 x minus 4s for each term, it usually helps you. Now on this side, it's times 0, so that's simply going to be 0. Here our 3 cancels, our x minus 4s cancel, so we have x plus 6. Our x minus 4s cancel, so we have negative 3 times 5 is negative 15. Our 3 cancels, and we have negative 2 times x minus 4. So 0 equals x plus 6 minus 15 minus 2x plus 8. Now combining our like terms, we have x minus 2x would be negative x, and 6 minus 5 plus 8 would be negative 1. 6 minus 5 is negative 9 plus 8 is negative 1. Then we can either add 1 or we can add x. If we add 1, we're used to adding our constants anyhow, so we have 1 equals negative x. Divide both sides by negative 1, and we have negative 1 equals x. Now, one thing we didn't do at the start of this one, which we should, was to see what numbers we had to eliminate from our domain, which would simply have been the x minus 4 equals 0, so x couldn't be 4. Well, our x wasn't 4. So we can write that's our solution set. And we've written it so far as x equals negative 1. We could also write it as the solution set is negative 1. So there's different things. If you have two equations, there are different things that you can do. You might need to find the value that would make them both true. In that case, you can set them equal to each other. You may need to find a particular value where you're adding or subtracting them to give you a particular value. Or you may want to find the 0, in which case you would set them equal to 0. We're going to look, as we work with our equations, there's actually 3 different types of equations that we can deal with. And these will just come about. We've already worked with several of them, but they have specific names. So an equation that is true for all values of x so that means it doesn't matter what value you substitute in, uh, it's going to be true. So it's true for all values of x is called an identity. Now, the way that you can tell that something is an identity when you're solving, because you've got to know, okay, how do I know if it's true for all values? So let's take this equation. 4 times x minus 7 is equal to 4x minus 28. Well, if we distribute, we get 4x minus 28 equals 4x minus 28. At that stage, since both sides are identical, you could tell it. But if we wanted to get our variables, if you didn't see it, and we wanted to get our variables on the same side, we would subtract 4x from both sides, and we would end up with negative 28 equals negative 28. That is a true statement. So therefore, our variables dropped out. We don't have any variables left, so there's no x saying that x equals, and we have a true statement, so this tells us that this is an identity. That is an N. It's an identity where it's true for all values. Now, if we look at another one, another problem, we have what we call a conditional equation. A conditional equation is one that is not an identity. So it's not going to be true for all of them. But it is true for at least one value. Okay, it's not an identity, so it's not true for all values of x, but it's true for at least one value. An example, we've been working a whole bunch of conditional equations. So 4x plus 5x equals 9. So 9x equals 9. or x equals 1. This isn't true for all values, but it is true for at least one value. So this is called a conditional. This is true on the condition that x equals 1. When x is 1, then this would be true. An identity is true for all values. It doesn't matter what value for x I substitute in. If I had substituted in a 1, then I would have 4 times negative 6 is negative 24, and 4 minus 28 is 24. It was true for 1. If I had substituted in a 2, 4 times 2 minus 7 is equal to 4 times 2 minus 28. So that would be negative 5. 4 times negative 5 is negative 20. This is 8 minus 28, which is negative 20. And we could keep going, and it would be true for every value that I substituted in. A conditional is true for that one value, and sometimes there may be two, but it's not true for all of them, but it's true for at least one value, so that when we substitute that in, it makes it true. The third type of equation that we want to look at is one that's called inconsistent. So an inconsistent equation is one that is not true for any value. And when we get into our systems of equations, we'll talk about our systems being named very similar to this. So this is not true for any value. Now, the way that you would know that an equation was inconsistent, well, let's take this. We have 2 over x minus 2 is equal to 3 plus x over x minus 2. Now, we know that x cannot be 2 because that would make our denominator 0. So if we go through and we multiply by our common denominator of x minus 2, okay, the x minus 2's cancel and we end up with 2. Using our distributive property, 3x minus 6. Our x minus 2's cancel, so we have x. So we have 2 is equal to 4x minus 6. We would add 6 to both sides, and we end up with 8 equals 4x. Dividing by 2, we get dividing by 4, we end up with 2 equals x. But x cannot be 2 because that would make our denominator 0. So this has no solution, or it's inconsistent. Now, it can also just be an equation. Let's say we had the equation 2x plus 6 equals 2 times x minus 5. Well, we have 2x plus 6 equals 2x minus 10. If we add 10 to both sides, well, let's go ahead and get rid of our variables. So if we subtract 2x from both sides, we have 6 equals negative 10. Our variables dropped out just like they did with an identity, but what we have here is a false statement. 6 doesn't equal negative 10. So lets us know that there's no solution, or that the solution is the empty set. Okay, we can do this with paper and pencil. We can also work with this on our calculators, and there's some things that we can see as we go through and we work with it. And so that's what we want to look at this point. So let's pull up our calculator and let's look at what we have here and as we're working with this. Uh, let's put into our calculator a couple of equations and just see what we're going to have. If we pull up our screen, our y equals, okay, if we pull up our y equals screen, we're going, and for some reason this isn't pulling up. Okay, okay, there's my cursor. Okay, so we have our y equals, and let's take the equation. We've got 3 times 2x minus 5. Now what we're going to want to do with this, we're going to take this equation, 3 times 2x minus 5, and then we're going to take another equation, 5x plus 2. And what we're going to do is like what we did a while ago on paper and pencil. We want to find the value that would make both of those true. And so one way that we can do it, and y'all know about, we could graph these. And we could go through to find our values. Now we can see on this case, they're off the screen as far as where our value is. And so we may need to go through and change our windows so that we can see those values. Or we can go through our table and arrow down so that we can find out where those values are. If we could look in our table now, arrowing down, what we're looking for is finding an x value and finding the value where both the y's are the same. And this is one way that you can tell it from the table. And so if we go on down, our y values are getting closer to each other. And you can see at where x is 17, both the y's had the value of 87. And so that lets us know that that's the value for x that makes both of the y's true. And you can tell that from the table. Now, as I said, and we're not dealing with the graphing of this right now, so I don't want to go into a lot on the graphing, but if we changed our window, we don't really, our negative 10 is fine, but on our maximum on our x, since we already know that it's x equals 17, let's just make a maximum of 20. And in this case, we want to also see what the y value is, which we're not going to deal with the y value at this point, but let's just make it 30 so that we can see the graph and make sure that we can see, well, we can't. So let's just make that super big. And again, we're not trying to deal with what our y values are. In this case, we're only solving for our x's. And we still didn't get it. I guess I should have checked on that part first. We'll make it enough that we know it's going to cross, because they were almost crossing at that point. Okay, and they cross up here at some point, which I guess I should have looked at this. They would have crossed at 87, so that should have let me know what I needed to make my y value for. But what we're looking at is this is just another way that you can deal with it. We're wanting to know where these two equations are equal. And so the way that we know that is by finding the x value that both of them, where they both have the same y value. And there's a few problems that you're going to deal with where they're going to give you the two equations. And so if we went back and we were wanting to show what we had, what we found is 3 times 2x minus 5 equals 5x plus 2. We could have actually solved that system, and the solution would have been x equals 17, because at that point, both of your y values are the same. So there are some other ways that you can go about solving these other than just using paper and pencil. But you need to understand what you're doing with paper and pencil, and then possibly you could go back and check your problems by using your calculator. So this is looking at then solving linear equations, finding where two linear equations have the same value, and then also dealing with the different types of equations that we have. We have our identities, where every value makes it true. We have our conditional equation that's not an identity, but it's true for at least one value. And then we have our uh, inconsistent equation, which is one that's not true for any values.